Alright, today we're going to be using the TI Nspire calculator, and we're going to use its graphing function and table function in order to solve linear equations and evaluate them without the use of inverse operations. So let me show you what that looks like. Let's go ahead and go down and look. We have a couple examples that we're going to pull from these notes that I created. And if you look at this first one right here, I have 5 plus 2x is equal to 2x plus 6. So we're looking at an 8th grade problem, right? So we have variables on both sides of the equal sign. And what we're going to do is, first of all, I'm going to go ahead just as a reference. I'm going to show you what the answer would be if we just take a look at nsolve. So menu 3.1, and I know I did this in another video, but we're going to go ahead and do this just so you can see what it looks like from both perspectives. So this first problem, I actually have 5 plus 2x is equal to 2x plus 6. Now I'm going to put that in. I'll hit comma x just to get a reference. And notice it says that I have no solution, right? So this is one method that I show the students with nsolve. But now what I'm going to do is show you that I can get that same answer if I just go to graphing. So I'm going to go ahead and go home. Now my favorite graph feature to use is this one that has the parabola at the bottom. The reason is during the test the students get stressed, and a lot of times they will forget to open up the tab, where you got to hit tab, T-A-B, in order to open up this entry box where it has your f of x, so you can put in your function. And so I always have them go to that one, and that way they don't get stressed out and forget. But what I'm going to do at this point is I'm going to put in the left side of the equation. When I say the left side, if you look over here, right, this was the equation I'm using, this example one. And notice it says 5 plus 2x. So I'm going to go ahead and put in 5 plus 2x. And now that I've got it in, I'm going to hit enter, and it's going to graph it for me. Now that that's done, I'm going to go to the right side of the equation and put in 2x plus 6. Now to do that, we do have to hit the tab button to pull up that option to enter it. And then we have 2x plus 6, and I'm going to hit enter again. Notice that I now have two lines appear on my graph, and I want you to notice that they are parallel. And so this is what I point out to the students, that we have a condition to where we have two parallel lines. And when they see that, I always mention to them that if you have parallel lines, there's no place at where the two lines intersect. And if there's no place where the two lines intersect, then that means that there is no solution. So at this point, for a lot of them, it's kind of an aha moment. Many students have never realized that whenever they're solving an equation, they're actually trying to find the value of x where the two lines intersect one another. And so I tell them this is just another tool that they can have during a test. And if a lot of them like using the graphing feature, and it's a really easy way to find answers to equations or verify that the answer that you got when using inverse operations is correct. So now what I want to do is let's look at another problem. So that was one example. Let's look at another. So if we go to this next problem, let's go ahead and go to this one right above right here. So notice that's problem number 1. I'm going to go ahead and I'm going to type that in. So I'm going to exit out of here. I'm going to hit enter on graph to go again, and I'm going to type it in, parentheses and all. And notice this, just so you know, this calculator is in test mode, so you can actually use this feature. The students can use it during STAR test. So I got 4 parentheses x minus 6. I'm going to hit enter. That is my first line. Hit tab, and I'm going to type in the second one. 6 parentheses x plus 2, and we're doing problem number 1. And I'm going to go ahead and hit enter. And now that this is done, of course you can't see where they intersect, but you can tell by looking at them they're not parallel. Now I'm going to hit menu, and I'll show them how to go through here and zoom out, because in order to use the feature we're about to use, we do have to zoom out, and we have to be able to visibly see the point of intersection. Now I can see where they intersect. I'm going to hit escape. Now obviously if you looked at this, it looks like it's kind of hard to tell where it hits. You know, it's down here somewhere, right? But who knows what that is? So what I tell the students is once we can see the point of intersection, we're going to hit menu. We're going to go down to analyze graph. And then we're going to go down to intersection. So option 4. I'm going to hit enter. I am going to move this lower boundary. I set it at the left side of my intersection, drag it over to the right, and I want you to notice it gave me my x value. So my x value right here is negative 18. And I tell them, right, the whole time we've been solving equations, it's always in relation to x, and we just want to see what is the x value at the point at where they cross. So now these two lines, we know they cross at negative 18. That is my answer. X is equal to negative 18. I didn't have to use inverse operations or do anything mathematically. I just entered into my calculator. But let's verify this is correct with numerical solve. And I would always do this for the student once we find it with graphing, is to verify with numerical solve, because you'll still have some of them that are looking at it and they're going, I'm not sure about this, Mr. H. So I'll say, well, you know what, let's check it with numerical solve real quick so I can show you that these are both ways that you can figure out what the answer is without doing it by hand. So I'm going to type it in real quick. So we have 4 parenthesis and we have x minus 6 close parenthesis equals 6 parenthesis, and we have x plus 2. Now you may notice that I'm putting in an x instead of a k. If the k's in there, they could put the k and they'd have to put comma k. But I always tell my students to always just use x's in place of the variable. And because if you don't, what I found is during test time when they get stressed, they'll put in like a letter k, for instance, in here. And at the end, they'll put a comma x for some reason. And they can't figure it out. And you can't tell them during test, right? Because you're trying to see what they know. So at this point, I just tell them anytime you have variables, don't worry about it. Just go ahead, if you're using numerical solve, just put it in as x and have no concern. Now I'm going to go ahead and enter. Notice it gives me the same thing. It gave me negative 18. So whether they get a graph and they graph it to look at the point of intersection, or whether they put it in numerical solve, they can get the same exact answer. So now they can do it by hand using inverse operations, numerical solve, or they can check it with graphing. So now let's go ahead and let's look at another type of problem that's a linear equation, right? Let's look at when we evaluate functions, because we can also use graphing and we can use the table to help us with evaluating functions. All right, so when we go to evaluating functions, I'm going to use, let's see, I think I'm going to use this third option right here where it says s of x equals 2x plus 14. So if I wanted to solve that, right, and notice it says evaluate s of x when x is equal to 24. So if I wanted to do it that way, and I can go ahead and I can type it in real quick. So let's say I had 2, and in place of an x, I'm going to put my parenthesis, right? And I'm going to put in 24, close parenthesis, and then I'm going to go ahead and put plus 14. And this gives me 62. Now, this seems very simple, I think, to a math teacher, at least to myself. We're just substituting for a variable. A lot of students struggle with substituting for variables for some reason in 8th and 9th grade. And so what I would do is I would show them this method, and I would say, look, this is how we should do it. You can even work it. We'd even work some out by hand in the class. And then I would go ahead and say, let me show you another way you can do it if you find this easier. Because a lot of students really like using the calculator. And in this case, we can use graphing to do it. And so what I do is I come over here and I say, well, you know what? Let's put this function into the calculator and graph it. 2x plus 14. And I hit enter. And then I tell them, look, you've graphed a line. And our goal here was to find what is the value of s of x, right? Which is basically y, when x is 24. And so what I tell them is, we're trying to find it when the x value is 24. Now we could look at the picture, right, and come along here and find 24, but that might be kind of difficult and it may be time consuming. But this is where we're going to use our table. We're simply going to go and hit control, and then we're going to hit the letter T as in tango. And once we hit that, notice it pulls up our functions table. And so what I tell them is they can simply go over here to the x values, that's on the left, that's your x values, that's your y values, and then they can just click down until they get to 24 for x. And once they get to 24 for x, the value on the right is going to be your y value. So s of x is equal to 62 when x is 24.